Write down viscosity. Viscosity is nothing but friction. You have two blocks, they move against each other, they have relative motion, and friction acts between these two. In case of liquids, this friction is called viscosity. Viscosity is nothing other than the concept of friction. This effect of viscosity is defined mathematically in this form. Suppose you have a liquid with different layers. From the top, this is Z. This is dz. So you have a big tub type of thing or a tube type of thing which is open at the top. Liquid is flowing. At a distance of z, you found that liquid layer is moving with v. The other layer at a distance of dz, further distance of dz, it is moving with v plus dv. Different layers, different speeds. Then we define a term which is called velocity gradient. What is velocity gradient? Velocity gradient is called dv by dz. Gradient means change divided by change. Change in the speed divided by change in the vertical position. That's your velocity gradient. Force of friction or force of viscosity, which is acting between these layers, is proportional to dv by dz, this velocity gradient, and more importantly is proportional to A. I guess you remember this friction had nothing to do with A. This is the only difference. Viscosity, the force of the viscous force, it depends upon surface area of a given layer. अगर बिल्कुल डीप में जाओगे तो ये A पर भी डिपेंड नहीं करता है, लेकिन कैसे करता है यहां देखना. If you have a block and you place it like this, let me draw a lengthier block, this, or you place it like this. We used to say that in both cases friction is what? Same, because friction has nothing to do with surface area. You try to pull this thing, you try to pull this thing, coefficient of friction is same and force of friction will also be same. Whereas in this case we say that if the area is A, then viscous force is proportional to area. अब जरा इस पार्ट को समझना. लिक्विड्स के केस में आप ऐसा सिस्टम नहीं बना रहे हो. आप लिक्विड्स के केस में क्या कर रहे हो? Let's take this block. If I place another identical block, this is basically this concept. हमने क्या किया, हमारे पास एक लेयर है, this is one. If I have another one, I have increased what area? Viscous force is proportional to area. But I hope you can see that if this is one layer and I increase the area, the whole thing is equivalent to having two identical masses. And if you have two identical masses and you try to push or pull this thing, then force of friction acting on the whole will be 2 mu mg. Force of friction over here is only mu mg because it's mass m and it's mass m. You have simply flipped it over and therefore instead of this it lies like this. So in this situation it doesn't depend upon the area, but for a liquid it does depend on the area. Why? When I say I'm increasing the area of a liquid, I am basically increasing its mass. If you understand the concept of A, how come viscous force depends on A, how come force of friction does not, and how come this A is basically not present. If you understood the feeling, then write down yes in the comment box, and if you could not, then write down no. The first response is no. The first response I've got is no. Let me look here. So this is one layer, mass m. Try to pull this thing. Another layer. For liquids, we do not need their mass. When we talk about force of friction acting between the layers, we are not interested in their individual masses, but more fundamentally what is happening, if you have a layer of this much area and then I increase surface area by adding more liquid, I am effectively doing what? I am increasing the total mass. So if I increase the total mass, then force of friction over here was mu mg, force of friction for this one is also mu mg, all together it becomes what? 2 mu mg. हमने क्या बोल दिया? हमने बोल दिया कि भाई एरिया बढ़ाया है इसलिए फ्रिक्शन बढ़ गया है. वो तो यहां भी होता है. आपके पास एक सिंगल ब्लॉक है, आप उस सिंगल ब्लॉक का एरिया चेंज करते रहोगे, बट इफ यू डू नॉट चेंज द मास, then force of friction will remain same. If you are trying to pull this block, if you are trying to pull this duster, you pull it this way or you pull it this way, you're not changing the mass. But now imagine pulling two dusters side by side. If I place them side by side and if you pull the whole thing, then definitely friction क्या हो जाएगा? Increase हो जाएगा. तो आपके पास एक डस्टर है, ये किया, we say that friction has nothing to do with area. एक डस्टर है, उसके साइड में एक और डस्टर है, आपने खींचा, we'll say that friction depends on area. This system of duster is nothing but these liquids. I hope now the thing is clear. So the person who said no and the other one, I hope they are comfortable with this thing. I will take 5 more minutes. Keep looking like this. So force of viscosity is found to be proportional to dV by dz. Now, if you remember again friction, what was friction? Friction was, it opposes relative motion. Relative motion, dV. Difference of speeds is what? dV. What is dV? That thing, relative motion. Now in this case, this dV, we need to define what is the separation between the layers. So instead of using simply the concept of dV, we also define that this layer and this layer, they are separated by a distance of dz, and they have a velocity difference of dV. This dV by dz is similar to relative motion of friction. So whenever we talk about viscosity, we are basically talking about friction. Now, this force of viscosity is proportional to minus of eta A dV by dz. This term eta is called coefficient of viscosity. ये जो म्यू था, इस म्यू की जगह हमने यहां पर लिक्विड्स में थोड़ा डिफरेंट दिखाने के लिए क्या टर्म यूज किया हुआ है, eta, which is called coefficient of viscosity. There are a few guys present. Can I take 5 more minutes or should I continue in the next class? What do you think? How many of you can give me 5-10 minutes more? Or should I continue this thing in the next class? Yes, yes, yes. Good. Write down this much fast. Wrote down everything fast. Everybody understands what's the meaning of negative sign? Viscous, friction. It's opposing. Negative sign is giving you the opposite sense. And with eta, write down this is coefficient of viscosity. Now this is for a situation where you have different layers moving with different speeds and all. Situation like this, you have a, just imagine a canal. This is the flow base, and then liquid is flowing, water is flowing. It's a canal and water is flowing this way. You all can see that the top surface, the free surface, which is in contact with the air, this is the fastest moving layer. And the layer which is at the bottom, we can also say that almost is at rest. It is in contact with the floor of the canal and therefore is almost at rest. Quite logical. The very atom which is in contact with the floor is not able to move. So velocity is increasing as you move up. Velocity is decreasing, therefore negative sign. The viscous force which acts between two layers is proportional to the area. So if you increase the surface area, if you increase the cross section of the canal, you understand that if I increase the cross section, I'm basically increasing the mass which can flow, and that way it basically depends on the area. And then if you go for this layer and this layer, this layer and this layer, and you ask the force of friction, which is viscous force, then it will depend on relative motion of this and this against each other. That relative motion is dV. So this is one effect of viscosity, where viscous force is simply called minus of eta A dV by dz. And then comes Stokes' law. You will find a few questions on this Stokes' law. What Stokes' law is, Suppose you have a big tank filled with liquid, and in this liquid, the tank, there is a ball which you dropped. As this ball goes down, there are three forces acting on it. One is what? mg, gravity. The other one is Fu, upthrust, buoyancy force. Archimedes is upthrust. And since it is coming down with V, all the liquid which is present by the side, it is rubbing against those layers, and therefore it also has an additional force of Fv. This V for viscous force. So when you drop something inside water, there are three forces acting: mg, upthrust, and the viscous force. This viscous force, it depends on what? Velocity gradient. Faster it moves, greater will be what? Viscous force. So what Stokes found? He found that this viscous force is basically 6 pi eta r v, where r is the radius of this thing. So if you have a spherical ball, its radius is r, then he observed that the viscous force is given by 6 pi eta r v. You need to remember the result. Now, when everything is in equilibrium, at equilibrium means what? First, let me explain the meaning of equilibrium. It's a dynamic equilibrium, things are moving. Just when you drop it, imagine, at the highest point, just when you drop it, when you release it, V is 0. If object is coming down, then it's obvious that it's denser than water. Then only it will come down. Otherwise, it will simply float. And if it is only floating, there is no effect of viscosity. So when you release it and it starts coming down, then it is very much clear that object is denser than water. If it is denser than water, it starts coming down because mg is greater than the upthrust. As it comes down, V increases. If V increases, your viscous force increases. Now, as your viscous force increases, just look at the numerical data. For your understanding, mg is 20. Suppose F upthrust is 17. Just suppose. So what is net force at the very beginning? Right at the top. 3. 20 minus 17, which is what? 3. And therefore it's coming down. As it comes down, V increases, and it becomes what? 1. अब कितना है net force? 20 नीचे, 17, 1, 18. Net force अभी भी कहाँ है? Downwards, 2. 20 minus 1 minus 17. 20 minus 18. नेट फोर्स कितना है? 2. किधर? डाउनवर्ड्स. स्पीड क्या होगी? इंक्रीज. स्पीड इंक्रीज हुई. दिस वन डायरेक्टली, दिस वन becomes 3. The moment it becomes 3, what is net force now? 20 down, 17 up, 3 up. That is 20 up. 20 down, 20 up. What is net force? 0. Should it stop? Should this ball stop? No. This is the time when force has stopped changing. There is no net force acting on this, and therefore when you get an equilibrium, this V becomes constant, which is called terminal speed. What is terminal speed? एक बार यहां फिर से देख लेना, शायद किसी को क्लियर नहीं हुआ हो. 20 17, 0 at the very beginning, at the top. This 0 is the viscous force, 17 is the upthrust. थोड़ा सा नीचे आया 20, 17. Upthrust is not going to change. What is the formula of upthrust? Volume submerged, entire volume is submerged into density of liquid into G. So this is 17, but right at the top over here you have a net force of 3. दिख रहा है आदमी को भाई कितना फोर्स है यहाँ पर 3. In blue you are looking at the total force 20 minus 17. किधर है टोटल फोर्स? नीचे. इसलिए नीचे की तरफ स्पीड क्या होगी? इंक्रीज होते ही हमने बोला that this becomes directly यार टाइम नहीं है, this becomes 3. If it becomes 3, your total force is now 0. Downward arrow ऐसे लगा दिया. Total force is now 0. If total force is 0 and this ball is already moving, then we are using concept of inertia of motion. An object is moving, there is no net force on it, it will continue with that same speed. Which is called what? Constant speed, that is terminal speed. And if they ask you find out the terminal speed, now you have the answer. When you are at this stage where V is constant, we have found that total force is 0. If total force is 0, then it means what? mg is equal to upthrust is equal to viscous force. There. What is F total? Downward kitna rate? mg. What is the formula of upthrust? Volume submerged, it's a spherical ball, 4 by 3 pi r cube. What is upthrust? Volume of object submerged inside the liquid into density of liquid into G. mg is this plus force of viscosity, which is 6 pi eta r v. What is this v? Terminal velocity. I'll just give you 2-3 statements, but before that, tell me, do you understand this part? That F total is 0, and since F total is 0, speed is not going to increase further. Are you comfortable with the concept of terminal? Yes or no? Fast. Good. Write down the statement. When an object is dropped in a liquid, viscous force acting on it is proportional to its speed. Viscous force acting on it is proportional to its speed. And therefore, as the object moves, total force decreases and at equilibrium becomes 0. And at equilibrium becomes 0, which means now speed cannot further change or increase. Now speed cannot further increase. Why? There is no net force. What is that which changes speed? Acceleration. What is that which produces acceleration? Force. So if you are saying that there is no force, there is no acceleration, there is no acceleration, there is no increase in the speed. This speed is called terminal speed of an object. This speed is called terminal speed of an object. Now, first, they'll ask you a simple thing. If you drop anything, not inside a liquid, just talk about a parachute. So when somebody jumps with the help of a parachute, then as he is coming down, does it happen that speed is continuously increasing? Answer is no. That parachute is like this ball. The parachute, the whole parachute and the person attached to that parachute, it's like a ball. And the air is like the liquid. So as he jumps from the plane and is coming down, his speed is continuously increasing initially. But then, after some time, speed is such that viscous force and upthrust, they both are equal to what? Weight of the body. And therefore, it becomes safe for him to land. Otherwise, आपने अगर पैराशूट से यूज किया, नीचे आए और स्पीड लगातार बढ़ रही है, then it's not safe. And then you can look at the R part. If you increase the size of the parachute, larger the parachute, more will be what? Viscous force. And therefore, if you are increasing R, and you have to equate LHS with RHS. So if you increase R, you must definitely have lower value of V. कम स्पीड से आप क्या करोगे? लैंड करोगे. आपकी जो टर्मिनल स्पीड है वो क्या होगी? कम होगी. तो इट्स नॉट दैट कि आपको पैराशूट लगाओगे तभी है. आप भगवान न करे आप ऐसा करो, बल्कि करना ही नहीं. कि अगर आपने जंप किया, करना मत. अगर आपने जंप किया तब भी आप एक टाइम के बाद आपकी स्पीड क्या हो जाएगी? कांस्टेंट. ऐसा नहीं हो सकता कि आपकी स्पीड लगातार इंक्रीज होती रहे. बट सिंस योर आर इज way too small, this V will be large and it's not safe for you to land. That's the reason we use good parachutes and all. This is about viscosity, Stokes law and all these things which come under the viscosity part. If you are comfortable with the Stokes law and all, everything which I taught you, then write down yes in the comment box and then you can leave. Thank you very much.